In the world of camel racing, you're talking about huge stakes, high speeds, and millions of dollars on the line. And to get that winning edge, some people are turning to a pretty controversial practice: blood transfusions. So today, we're going to unpack the science and the ethics behind this whole thing.
It's a fair question, right? I mean, why would you give a blood transfusion to a perfectly healthy, elite animal athlete? It's not for an injury or an illness. So what's the real goal here? Well, that's the central mystery we're going to solve in this explainer. And look, this isn't just some wild rumor. The scientific paper that we're diving into today makes it super clear that this has become a pretty common practice in camel racing across the Gulf countries. So a team of researchers decided it was time to find out what really happens when you put this practice under the microscope.
Okay, so let's get into it. How did these scientists actually investigate this? We're going inside the experiment that pulls back the curtain on what's really going on.
You know, the setup was actually beautiful in its simplicity. They took 5 healthy racing camels, took a blood sample to get a baseline, then they gave each one the exact same amount of blood, 900 milliliters, from the same donor just to keep all the variables the same. And then, 2 days later, they took another blood sample. It's a classic before and after experiment.
So what's the first thing they found? Well, no surprise here. They found the exact reason people are doing this in the first place: a huge, massive surge in the very engine of athletic performance.
And the results? I mean, just look at this chart. It's pretty striking. This shows the red blood cell count. You know, the cells that carry all the oxygen to the muscles. Before the transfusion, the average was about 9.7 million per microliter. But afterwards, it shot up to 11.7 million. That is a gigantic leap.
To put that in perspective for you, that's more than a 20% increase in the camel's oxygen-carrying capacity in just 2 days. From a pure performance standpoint, that's kind of like slapping a turbocharger onto an engine.
And it wasn't just the raw cell count. 2 other really key metrics: hemoglobin and hematocrit, which are basically just other ways to measure how much oxygen the blood can carry, they skyrocketed by an even bigger margin, over 28%. The takeaway here is crystal clear. The procedure absolutely supercharges the biological machinery needed for endurance.
Okay, but this is where the story takes a really sharp turn. A boost that big, that fast, it almost never comes for free, right? So what did the scientists find lurking just beneath the surface? What was the biological price the camel had to pay for this crazy performance enhancement?
It turns out, the data revealed a pretty serious hidden response. The camel's body was reacting to this transfusion in ways that were, well, let's just say they were far from positive. And this, right here, might be the most powerful piece of evidence they found. The scientists saw a clear sign of something called hemolysis, which is basically the destruction of red blood cells. So on the right, that's the clear blood serum from before the transfusion. But on the left, see how the sample taken after is all reddish? That color is from the new transfused red blood cells literally breaking apart and dying inside the camel's bloodstream. Not good.
And the complications didn't even stop there. Get this. Take a look at the platelets. Those are the cells that help the blood clot properly. Their numbers took a nosedive, dropping by a pretty significant 19%. This suggests the transfusion was kicking off some coagulation issues, maybe a sign that the body's immune system was really struggling to deal with all this foreign blood.
So, okay, we've got a performance boost, but it comes with a real physical cost. But maybe the most important discovery for regulators and veterinarians was something else entirely. A kind of biological fingerprint that the transfusion leaves behind. A smoking gun, if you will.
So to get this next part, we need to talk about something called reticulocytes. The easiest way to think of them is as newbie red blood cells. They're immature cells that the bone marrow pushes out into the bloodstream when the body senses it's losing or destroying red blood cells. You know, like in the case of that hemolysis we just saw. They're a sign that the body is scrambling to replace what's being lost.
And would you look at what happened to their numbers? Before the transfusion, the count was sitting around 14.6 billion cells per liter. But after the transfusion, as the body started destroying those foreign red cells, the bone marrow just went into overdrive, pushing the reticulocyte count all the way up to 22.6 billion.
Now, here's why that's so important. The scientists drew a really powerful conclusion from this. They state right there in the paper that this spike in these newbie red blood cells remains steady for a long time. And that's the key. It creates a reliable long-term marker, that smoking gun, that proves a camel has received a blood transfusion.
So, after all of this, what's the final verdict from the researchers who ran this whole experiment? Let's put all the pieces of the puzzle together.
It really just boils down to 3 key takeaways. First, the boost is absolutely real and it's significant. Second, the cost is also very real, with clear evidence of red cell destruction and other health complications. And third, the signature, that spike in reticulocytes, gives officials a clear, lasting way to actually detect the practice.
And all of this brings us to their final recommendation. Based on all the evidence, the scientists conclude that this just isn't a performance tool. It should be a very, very limited medical procedure, only for camels that are genuinely sick with severe anemia, and even then, only under the strict supervision of a vet.
And this really gets to the heart of the matter, doesn't it? It leaves us with this huge question. When you take a medical procedure out of the clinic and onto the racetrack, it raises this fundamental ethical problem that goes way beyond camels. In any sport, in any high-stakes competition, where exactly do we draw the line between legitimate therapy and unfair enhancement?